Last thing that we need to talk about for this unit is angles. So we are going to talk about how to measure angles, how to classify them, how to name them, and then we're going to be looking at different types of angles. Did everybody find these notes? Okay. First thing that we need to start with is naming an angle. So first of all, here is a picture of an angle. An angle has a vertex and it has two different sides. It's measured in something called degrees. Okay, here we go. You have to name an angle using its vertex. That's one way. So looking at this picture right here, I could call that angle A. And there's actually a symbol for it. You don't have to write out the word. There's a symbol for it. Now, sometimes there are many angle A's, and so oftentimes that is not going to be sufficient. So oftentimes what we do instead is we use the vertex and the two sides. And so when we do that, it's going to say angle, and there will be 3 points that we use. In the middle, it has to be the vertex. So our vertex is A. And then we pick a point on either side. So if this is our vertex, picking points on either side, C and B. So that is one possibility. The A has to be in the middle, but the C and the B don't matter. So I could call it angle CAB or BAC. Either one means the same thing. But what is important is that the vertex is in the middle. And then sometimes we put a number in the angle, and so we could also just call this angle 1. I would say the second and the third are the most common. Those are the ones that are the most common. Okay, so if we take a look at this one, this example, a lighthouse keeper measures 3 angles made by the lighthouse, point M, and 3 different boats. Name the 3 angles in the diagram. Okay, so first off, I want to make sure we know what angles are being referred to. There's this little, well, first of all, there's the whole angle. And then there's an angle here, and there's an angle here. And so I'm going to put numbers by them. So we have angle 1, we have angle 2, and the whole thing is angle 3. And so I'm going to name them using letters. Now, I told you above that this first way of naming by the vertex isn't the most common because sometimes there's more than one angle. So this angle 1, its vertex is M. If I were to call it angle M, bless you, that's a little unclear. What angle M am I referring to? This angle 1 has a vertex of M. This angle 2 has a vertex of M. This angle 3 has a vertex of M. So this really isn't ideal. It's not specific enough. Instead, we're going to choose 3 like we did above. Vertex has to go in the middle. So M has to go in the middle. So now if I look at this angle, I'm just picking points on either side of it. So this side has a point of J, this side has a point of K. So we put those on either side. I also could have named this angle KMJ. So I can reverse the order. The M has to go in the middle though because it's the vertex. So angle 2, similar idea. This angle right here still has a vertex of M. That's still what is holding together our angle. On either side, we have K and L. And again, the reverse order will work also. What's important is that that M is in the middle. And then angle 3, the entire angle, the whole big angle. The vertex is M, so it has to go in the middle. On this side, I have point J. On this side, I have point L. So I can put J and L. Now, I can reverse the order. So I did that with 1. I didn't write it down for 2 and 3. How do we feel about that? Okay? Okay. You are doing this example. There are 3 different angles. I want you to name them. Please don't use just one letter. So take, I don't know, a minute and write those 3 angles, please. Let's go over this. I have labeled the angles 1, 2, and 3. You didn't need to do that. 1 is this little angle up here, 2 is this angle, and 3 is the whole thing. So I'm just going to call on a few of you and ask for you to help me out with the naming. AJ, can you name that angle 1, please, for me?
Angle CBD.
Great, love that. Thank you. Angle CBD. Or we could also do DBC. That angle 2, the bottom one. Thomas, can you do that, please?
ABD.
Angle ABD. Great. Also, I could call it DBA. Thomas, could I call it angle ADB? No. Wrong point in the middle. Thank you. And then, Berkeley, can you name the whole angle, angle 3, please?
Let's see. C, B, A.
Beautiful. Love it. Angle CBA. How do we do?
Good.
Good? Okay, questions before we move on? Okay. Next thing to talk about, angles are congruent if they have the same measure. If they have the same measure. Now, we noticed before with segments, so let's say this segment was congruent to this one, they were marked with a tick mark. You can do the same thing with an angle. So these angles are congruent. And if you put a tick mark, that shows that they're congruent. Shows that they have the same measure. Okay, so let's move on. Next thing is classifying angles. A right angle is 90 degrees. And the way we show that is with a box. A straight angle is 180 degrees. Then here are the 2 that are probably new to you. Acute is between 0 and 90. Obtuse is between 90 and 180. So we are going to do these 3 real quick. We are just classifying. So acute is 0 to 90. Right is 90. Obtuse is 90 to 180. And straight is 180. So if I say angle A is 43 degrees, Charlie, what kind of angle would that be? If angle A is 43 degrees, what kind of angle is that? Your options are acute, right, obtuse, or straight.
Acute.
Acute, great, thank you. Maddie, 180 degrees, what kind of angle is that? Straight, great, thank you. And then Kaylin, angle C is 110 degrees, what kind is that? Obtuse. Okay, are we okay if I just keep rolling right along? Okay, this postulate, all it says is that you're able to add angles together. That's all it says. I don't think we need to read through it. We're just going to take a look at this example. Okay, this is where we have to make sure we are okay with our notation. So it says the measure of angle LKN. So LKN is this whole angle. And that whole angle is 145 degrees. And then it's having us find other angles. I don't care about that just yet. Okay, all that postulate says is if I have a big angle like this, I can add up the 2 smaller angles to get the bigger angle. That's all it's saying. So if I take that 2x plus 10 and I add it to the other angle, 4x minus 3. So I'm taking small angle, add small angle. It should give me the entire angle. And that's what I'm solving then. So like terms, 4x and 2x, I have 6x. 10 and negative 3 is 7. If I subtract 7, I get 6x is equal to 138. Whew. I don't know what 138 divided by 6 is. $23. Chloe, do you think I'm finished? No, why not?
Because you have to plug it into where the X is on the...
Great, we got to plug it in to find some angles. Chloe, which angle is LKM? Is that the one on the left or the one on the right? Left. Okay, so LKM. LKM, this one right here. So if I take 2 times 23 and I add 10, so this will be 46, add 10. So the measure of angle LKM then is 56 degrees. So that's this one. So then if I want MKN, that is 4 times 23, subtract 3, which is 89 degrees. So our measure of angle MKN is 89 degrees. How does that check out? Why are we like, yeah, that makes sense?
So it adds to 145.
Great. Yes. Thank you. We needed a total of 145. So our 56 add 89 does in fact give us 145. And like I said, on quizzes and tests, you will be able to use a calculator, so I would suggest you try that. Questions before we just keep on rolling? Okay. These are the two that you were doing. So right now, move desks with the person next to you and give these two a try, please. Okay, let's now see how we did. Walking around, I saw a lot of great work. So, awesome job. I saw our setups, which was lovely. I saw that many of us got x equals 6 and plugged it back in. Amazing. We saw that a straight angle gives us 180. Few little tiny things. Your measure of an angle has degrees on it, so make sure we put degrees. And then did we do a mental check to make sure our answers made sense? Like, oh yeah, these did in fact add up to 180. Oh yeah, these did in fact add up to 102. Okay, we're going to go over one more thing and then we will take a break. Do you all have any questions for me before we talk about the last thing I want to talk about? No? Okay, before we even look, bisect. What does bisect mean? Cut in half. Okay, let's write that down because we've seen that word a whole bunch of times. To bisect just means to cut in half. So we've said you can bisect a segment, right? You can take a segment and cut it in half. You cannot bisect a line. A line goes on forever, so you can't cut a line in half. An angle bisector, it just takes an angle and cuts it in half. That's it. So we're not going to read all of that. All that means is you take an angle, cut it in half. This is where our notation is going to come into play. Okay, QS, I'm looking at the example. QS bisects angle PQR. So I'm going to start with angle PQR. So this is angle, put a dot P, Q, R. So we have 3 points. QS bisects it. So QS goes through the middle, so there's an S here. We need to show that this is bisected though. Right now, there's no way for me to know that this is bisected. If it's bisected, that means that this angle is the same as that angle. So that's what those tick marks mean. And then angle PQS. PQS. So looking at my figure, PQS, it's this one at the top. That is 24 degrees. We need to find PQR. So PQR, this angle, PQR is the whole thing. So we're looking for the whole thing. Now, from our notation, we know if this is 24 degrees, this also has to be 24 degrees. So then our whole angle, our angle PQR, 24 and 24 is 48 degrees. 48 degrees. Okay. I would like you all to do that last example, and then after we go over this, we will take a break. So you all do this example, please, and please draw a picture. So here is what I got, 79 degrees. Again, it's dependent on did you draw the picture correctly and did you follow notation? Or did you just assume it was the same as the one before? We were given the entire angle. So we were given the entire angle. If that angle is bisected, it's cut into 2 equal parts. So these 2 angles have to be the same to give us that 150. Excellent.
What does that M mean?
Measure. Yeah. So when you see the M, that's how we know we're looking for degrees versus just referring to the angle in general. So that's a great question.
Fantastic.
Okay. Ready for a break? Great, me too. We have some more definitions. You don't have to write them down though, they're already written down for you. Okay. Adjacent angles. They're just next to each other. That's all that means. Adjacent angles are next to each other. So 5 and 6 are adjacent. They share a side. They share a vertex. They're next to each other. The next 2 words are really important. Complementary angles add to 90. Supplementary angles add to 180. They don't have to be next to each other. So angles 1 and 2 we say are complementary. They form a right angle, hence that box. These 2 angles are also complementary even though they're not right next to each other, even though they're not adjacent. Okay, so let's take a look. I'm going to name some and then you're going to name some. Adjacent angles are just next to each other. So that would be this angle here and this angle here. They're next to each other. So if I name that 37, that is angle BAC. And that 127 is angle DAC. That's just one way of naming them. Complementary angles have to add to 90. So we're looking for 2 angles that add to 90. 37 and 53 add to 90, so those are complementary. The 37 rather, we've already named, that's angle BAC. And that 53 is angle RST. And then lastly, supplementary angles are going to add to 180. So that would be our 127 and our 53. So angle CAD and angle RST. I would like you to do the next 3. Take a minute or 2 to do the next 3 with the person next to you, please. Let's start going over. I'm going to call on a few people to give me some examples. Abigail, can you give me a pair of adjacent angles, please? I'm sorry, can you start again?
So angle DEG and angle FEG.
That's what you said, right? DEG and FEG? Great, thank you so much. Avery, can you give me an example of complementary angles?
Yeah. Angle ABC and angle HJK.
ABC, HJK, great, thank you, love it. And then Kai, can you do the supplementary angles, please?
FEG and DEG.
How'd we do? Good? Manny?
Isn't it supposed to equal 180?
Yeah?
But doesn't 108 plus 62 equal 170?
Okay, can you make an adjustment then so that these are supplementary?
Instead of FEG, you can do HJK.
Thank you. Janet?
So isn't complementary meant to have to 90?
Yes.
I have to get up to 100.
Huh. Can you fix that one then, please?
So keep ABC and then do FEG.
Okay, better? Stop. Kai, to be clear, I was mostly talking to you. Paxton a little bit, but you're the one who's like been looking over there the whole class and I've just been ignoring it. But now it's to the point where I'm not ignoring it anymore. Okay, moving on. I'm gonna do this one. I'm gonna skip that one. You're gonna do the next 2. Angle 1 is a complement of angle 2. Angle 1 is 62 degrees. Find angle 2. What does complement mean? They add up to 90. So if I take angle 1 and I add it to angle 2, I'm going to get 90 degrees. Angle 1 is 62 degrees. Really, this is something, my notation is poor here. Really, there should be an M for measure. I don't care if you put the M there, but that's what the M is measure. So the measure of angle 2 then is going to happen when I have 90 and I subtract 62. So angle 2 then will be 28 degrees. You all do the next 2, please. Okay, let's keep going. A, we are finding the measure of angle 5. Charlie, what did you get?
39.
Thank you. 39 degrees, because the angles add up to 90. And then finding the measure of angle 7. Kala, what did you get? Okay, can you give me some ideas now? Okay, what does supplementary mean? Adds up to 180. And if we have one angle of 29, how would we find its supplement? Great, thank you. Okay, how are we feeling? Good? Okay. Anybody going to be upset if we skip the next example? Great. We really only have one more thing to talk about then. We have one more thing to talk about, 2 examples, and then we will move on with our lives. So we are going to skip this modeling example. The last 2 things we need to talk about are linear pairs and vertical angles. So a linear pair is like these 2 that you see below. In geometry terms, they are adjacent and supplementary. So maybe you want to write that down. In simple everyday terms, a linear pair is just 2 angles that form a straight line. Okay, and then vertical angles are just across from each other. So 4 and 5 are vertical because they're across from each other. So are 3 and 6. So vertical angles are just across from each other. So linear pair, they're next to each other. Vertical angles, they're across from each other. Questions before our last 2 examples? You are going to do both of these. I want to, though, start with this first one. You're naming all. When it says linear pairs, there are 8 of them. When it says vertical angles, there are 4 of them. Can anyone give me one example of a linear pair? So 2 angles that form a straight line. Paxton?
Angle 1 and angle 4.
Angle 1 and angle 4. So that is one pair. Can anybody give me an example of vertical angles, the ones across from each other?
Angle 1 and angle 3.
Angle 1 and angle 3, thank you. Okay, you are going to take 4 or 5 minutes and finish up naming all of those angles and this first example, the one in green that says teacher does. We're not going to do the last one.